Hello friends, today I will tell you about the mathematics on water budget equation for GATE exam and another exam. I will discuss 3 examples. On the basis of it, you can get an idea of the mathematics whatever come to this exam. So friends, like करो, share and subscribe भी करो. Now this is the first question. I have already discussed what is catchment area, what is the water budget equation and everything, right? And a hydrologic cycle, etc, etc. So now this is our first question. In the first question, at the first of that you can get the small catchment of 150 hectare area. 150 hectare, you should be notified that 150 hectare. You can convert it hectare to meter square after multiplication of 100 into 100, right? Area, and I have already told you that everything which is related to hydrology is related to surface area only, right? Because the water evaporates through the surface. Now this is a rainfall of 10.5 centimeter in 90 minutes due to a storm. Because due to a storm there is a rainfall occurs or precipitation occur sorry, it occurs, and due to that 10.5 centimeter depth has increased. At the outlet of the catchment area, the stream draining of the catchment was dry before the storm and experienced a runoff lasting for 10 hours with an average of discharge of 1.5 meter cube per second, and the stream was again dry after the runoff event. What is the amount of water which was not available runoff due to combined effect of infiltration, evaporation and transpiration? What is the, and second question is, what is the ratio of runoff to precipitation? Acha. Please pause the video and do that according to your knowledge, whatever I have discussed previously, right? Okay, I have pause the video, and after pausing the video we will try. If not, then I am discussing right now. Acha. Water budget I have already told you that water budget equation which is related to rainfall and runoff is here. R equal to P minus L. P is the precipitation and L is the loss and R is the runoff. This is the water budget equation, and due to this equation you can solve this question, right? Now you can get that there is a precipitation of 10.5 centimeter precipitation occurs through the catchment area of 150 hectare. So if you multiplication that with time, every I have already told you that this is which is related to continuity equation, right? So continuity equation always related to some amount of time DLT, right? That is the time DLT we have chosen here for 10 hours, because the runoff is lasting for 10 hours, and the period of the 10 hours there is only rainfall occurs 90 minute only, and the depth is increased 10.5 centimeter. Achha. Okay, now if you multiply that with time 90 minute, then you can get this amount of precipitation. After that there is a runoff occurs 1.5 meter cube per second discharge and for 10 hours, right? So if you multiply it with time, then you can get the runoff. And now if we subtract that from precipitation to runoff, you can get the loss due to infiltration, evaporation and transpiration. The first question you have done. Okay, and same question is ratio of runoff to precipitation. So runoff is, here is a runoff, here is a precipitation. If you ratio divide them together, then you can get the answer of runoff to rainfall ratio. Okay, this is our second question. Do you enjoy it? Right. Now come to the second question. A catchment area of 140 kilometers square received 120 centimeter of rainfall in a year. At the outlet of the catchment flow in the stream draining the catchment was found to be an average rate of 3 months, 6 months and 9 months. If we add them up, then you can get the total month of 12 months or 1 year. So here our delta is equal to 1 year only. Okay, now we can get the time. Now we can find what is the runoff coefficient of the catchment. Runoff coefficient, we have to determine runoff coefficient first. And if the second question is, if the afforestation of the catchment reduces runoff the coefficient to 0.35 due to afforestation, what will happen? In some amount of water losses, right? And the losses of water will be more. So what is the increase? The same question is, what is the increase in the abstraction from precipitation due to infiltration, evaporation and transpiration from the same annual rainfall of 120 centimeter, right? Now we have to determine the precipitation. Rainfall is 120 centimeter, right? So precipitation will be 120 in a year. All they have told you in a year, right? So this amount of precipitation, this amount of precipitation for 3 months, 6 months and 3 months, right? No, precipitation, that is not the precipitation, right? Sorry, that is not the precipitation, that is the runoff only. Precipitation is 120 centimeter. We can multiply 140 into 120 centimeter. We can get the by rearranging them according to their units, we can get this 168 million meter square, and runoff will occur by multiplication of these two D's, and the unit will in months, million meter cube in month. We have converted this in million meter cube. How we can convert it? You should have to notify that very carefully, that because 27 there is million meter cube, 27 what we have done, it is also there is a second unit, so we have converted it to according to days or month unit, right? So we have converted in multiplication of 60 by 60, it is converted to hour, and if we multiply with 24, it will convert it with a day, and 365 in a 1 year, right? If we divide by 12, so in 1 month, then there is that amount of days, and this is converted to hour, this is converted to minute, this is converted to second, right? So multiply this, we will get the answer of in million meter cube. Runoff coefficient is this amount to runoff by rainfall. So you can already in the first question we can get the runoff by rainfall. It is the runoff coefficient actually. So this is abstraction value. What will be abstraction value? If we subtract the abstraction value of the or the losses, actually here it is termed as abstraction value. So if we subtract that, we can get this. After afforestation, I have already told that due to afforestation, there is rainfall will increases. Sorry, runoff will increases. Rainfall is always constant. So runoff is due to constant of rainfall or precipitation is always constant. So if due to that, 168 is constant. With multiplication with runoff coefficient, we can get the runoff. New abstraction value. If we subtract that from that, you can get the new abstraction value. An increase in the abstraction, and due to in the previous abstraction is less, and now the abstraction is more. Because of the runoff, so we can get this answer, right? This is our third question, and please firstly Read the question carefully, then answer them. A lake had a water surface elevation of 103.2 meter above datum at the beginning of the certain month. In that month, the lake received an average inflow is at this from surface runoff source. In the same period of outflow from the lake, or average of this. Further, in that month, the lake receives a rainfall of 140 millimeter, and the evaporations of the lake will be estimated as 6.10 centimeter. Write the water budget equation for the lake and calculate the water surface elevations of the lake at end of the month. The average lake surface area can be taken as 5,000 hectare. Assume that there is no contribution to or from the ground storage. Right? I have already told what is the storage. There is 3 types of storage actually. There is air is taken as the ground storage. There is no adding or subtraction from there. Right? Please pause the video and I will discuss it. So now I will discuss. Firstly, you know that water budget equation. Write the water budget equation. I have already written that water budget equation is this: input volume minus output volume change in storage in the time of delta. Always told you. If you read the question carefully, then you get that there is a inflow value of 6.0. It is the inflow value of 6.0 and the outflow is 6.5. There is inflow due to the precipitation. There is outflow due to the transpiration. So you can get that from there. I have written that in that manner, and our time is delta is 1 month, so I have converted that in million second, and from there 6.0 is our inflow. There is multiplication with this amount. You can get this in million meter cube. Outflow is this. You can convert it in million meter cube. Right? So precipitation is PA. What is that? Precipitation is already told P into A. A is the area. Precipitation area is, what is the area? Is 5,000 hectare. And what is the precipitation occurs? Precipitation occurs is 6.10. Right? Am I right? Sorry. Lake received a rainfall of 145 millimeter. 145 millimeter of rainfall they have got. So 14.5 it is millimeter to centimeter. Convert by 100 it is meter, and 5,000 into this in meter cube, and by 10 to the 6 you can get it 7.25 million meter cube. And outflows of the evaporation is E into a evaporation depth and into area. 6.10 centimeter. If we divide it by 100, you can get it in meter. 5,000 into 100 by 10 to the 6, you can get it 3.05 meter million meter cube. By subtract this, you can get the value of 2.904 million meter cube. Change in elevation. Elevation change, how can I get it? By divided by area. This you can get this new water surface elevation. Previously your water surface elevation is this. Due to all of these things, water surface elevation may be increase or may be decrease. That depends on the calculation, right? And this by adding this up, you can get this. So these 3 types of questions give you the some basic things about the water budget equation and its application. Right now you can do the other problems also in your home. So please like, share and subscribe to my channel and inspire me to do the next videos. So please, thank you for watching. Goodbye, see you again.